record just in case there's a problem with the audio.
Oh, nice. Okay.
Do you want to start?
Kick it off?
Yeah.
Sure. Okay, so obviously we've been doing different types of proof of concepts on what we like to see for CodeBuddy's version 3. The proof of concept that I proposed was the serverless one, but with a little bit of a twist in the sense that we're leveraging Netlify as kind of the hosting solution for the front end, but it also recently allowed us to create Lambda functions within the same repo. So I created a CodeBuddy's account to essentially be able to integrate our repo on GitHub with Netlify. So it's just a simple integration where you can set up which branch you wanted to deploy from, what is your build command and whatnot. I don't know if a lot of people are familiar with using Netlify to deploy. I actually have my own personal website deployed on Netlify for free. And so it's a fantastic solution for a lot of this kind of pattern architecture people know as the Jamstack. So the exciting part is, I've been kind of looking into Lambda. In fact, I'm using AWS Lambda at work in a much more kind of enterprisey way. But nevertheless, it's still under the hood AWS Lambda. And Netlify recently launched the support for functions, which is essentially exposing the functionality of AWS serverless Lambda functions as kind of like the proxy for them. So they're kind of serving as the, what's that?
Oh, sorry, I said that was pretty cool.
Yeah. And so, they're kind of like trying to do like a kind of vendor solution on top of Lambda in order to kind of minimize and reduce a lot of the overhead and complexity and kind of configuring Lambda, because it's not as simple as just, logging on to something and saying, I want to create a Lambda function. And so there's a lot of complexity to that, and it requires you to have an AWS account and create some cloud formations and IAM roles and all this kind of jazz in there. So Netlify is kind of abstracting all that away from you. And it's essentially allowing you to just create these Lambda functions inside of your source code under its own dedicated folder. You can certainly peruse around the documentation. It's pretty straightforward on how to build and create Lambda functions. You do need to have some level of understanding of how Lambda functions are created, kind of what the signature of the function is, and what a handler exposing this handler method, if you will, inside of an AWS Lambda function. So once you get past that, everything else is pretty typical in the sense of using Node.js on the back end. In our case, I think we'll probably continue to do that. There is support for Go, I believe, under the functions for Netlify. But in my case, as part of the PLC for CBV3 was using Node and JavaScript. So that's kind of like the high level. Again, decent documentation. It's fairly new, but with the testing that I've done so far, it looks like it's ready to go. So let's walk through.
Does it require creating an AWS account?
It doesn't require you to create an AWS account at all, which is a nice thing. So you literally just create your Netlify account and tie your project to the Netlify account. And inside of your repo is where you define your functions. So if we want to take a look at, kind of head over to the code real quick, you'll notice that inside of our source directory, and what I ended up doing here was thinking about the concept of this one repo that actually manages both your you have your source code for your front end, but separately you have your source code for your Lambda functions in a different folder, but they're actually part of the same repo. So obviously there are plus and minuses to that. The benefit here is that we all work out of one repo, but you can technically still work on front end versus back end, right? And so that's a nice thing that it comes with leveraging like a create React app CLI to just bootstrap the front end. And it can be any project, but Netlify supports kind of out of the box a lot of these kind of other projects like Gatsby and whatnot. So in this case, obviously, I think we're kind of considering to still stick with React as a front end. I'm not sure if we're considering Vue or not.
We have a repo for Vue that nobody's worked on.
Okay.
I'm personally I don't know Vue at all, so.
Yeah.
Yeah.
I think a lot of people have kind of jumped on the React bandwagon, and a lot of people probably spent a lot of time and invested a lot of their learnings in React recently, at least in the last 3 or 4 years, that I think a lot of people are much more comfortable with it. But in any case, you can certainly use Vue on the front end in Netlify as well, and then still follow the same pattern.
Mm-hmm.
So in this case, I went with just the typical CRA, and so this is just bootstrapped. Outside of these Lambda folder here that I created, everything else is very kind of typical bootstrap of the Create React app, right? I didn't change anything. I didn't add anything in here. I really wasn't focused on the front end, to be honest with you, as part of the proof of concept, because it's fairly easy and straightforward to build your React app and call the backend, right? And so, kind of following that Jamstack pattern, you should be able to build that out. So that wasn't the focus. The focus was, can we leverage something like serverless, where you're not only are you hosting the front end for free, but you're essentially not even needing to host a all-time running server on the back end. So today we're running Code Buddies on DigitalOcean, paying for hosting every month, and that's because we're constantly running that server. In the serverless architecture, there is no concept of an always running server. What you do have is instances that get initiated or instantiated of servers, or VMs, if you will, right? That AWS fires off on you on the moment that you invoke a function. And so you essentially only get charged pennies on the time it takes to invoke and the number of times you invoke a function. And so there's definitely documentation out there. It gives you the pricing breakdown and kind of the typical use case may look like. But off the bat, the main benefit here is, if you went with a solution like this, and we understand that traffic may increase, and we understand that invoking functions may increase over time, but I think that we haven't seen the traffic yet on Code Buddies to be worried about that type of invocation counts. But I think they offer 125,000 requests per month, for example. Here it looks like they do 100 hours of runtime per month. And they even actually have a usage here that you can, I guess you can.
So in other words, all the costs will be paid to Netlify instead of having to pay a separate server versus database.
Yeah, you wouldn't, and today I think we're paying for DO to host the website, and then
MongoDB Atlas.
Yeah, MongoDB Atlas for the database component for our data store. Now, the database cost is not necessarily going to go away because everybody still needs a database, even in the serverless architecture.
Okay, I see.
So
that would probably be something on AWS then. Or, I mean, yeah. I guess it could be anywhere that we decide, but I think Netlify they've recommended AWS I forget the name, but it's one of their databases.
Yeah. Yeah, it's not one of theirs. They just support it. You talk about Fauna DB.
Oh, right. Yeah.
Um, yeah, but essentially any cloud-based service will suffice, right? As long as your Lambda functions can
Hmm.
access and call it, right?
Yeah.
Uh, and so that piece, I think if we wanted to stick with Mongo, for example,
Hmm.
we can certainly do so. But now it's also an opportunity to consider other services, other data store services that we feel like either one, they're cheaper, or two, maybe NoSQL is not an option anymore. Maybe we can feel more comfortable with a relational database, right? Like Postgres or MySQL.
Hmm.
Um, but the point is that yeah, that the database store need will still be there. But what you're doing is you're removing the cost of hosting a server.
Hmm.
You're also removing the cost of hosting, like if we had breaking this out, the API from the front end, you would today be hosting the front end somewhere else and the back end somewhere else, right?
Hmm.
Um, but because we were using the framework Meteor, we were kind of hosting it all in one, right? So it's all being hosted there. But in most cases, people have it broken out. Both of those hosting solutions will be reduced to just
Netlify.
one.
Yeah.
Exactly. And again, Netlify allows you to host any front end for free.
Hmm.
And so you kind of get the side benefit of not only hosting your front end for free, but now if you went with the serverless approach, you would also be hosting your backend for free up until you hit those limitations, right? Um, Once you start hitting over 125,000 requests a month, for example, then the pricing comes into play.
Hmm. Do you think
And even,
uh,
go ahead.
do you think it'd be possible to host the backend on DigitalOcean?
Uh, in what way? Like serverless way?
Um, if we host the front end on Netlify.
Oh
Uh,
yeah, yeah, absolutely. Like if we just took the conversation of serverless out of this picture, we were just talking about Netlify as a whole.
yeah.
Yeah, absolutely. We can create your own front end repo that is the CodeBuddy's client, for example, and that
Okay.
would be entirely hosted on Netlify for free. And yeah, you can
Hmm.
continue to have it talk on the back end to DigitalOcean.
Okay. Cool. Thanks for clarifying.
Yep.
Yeah.
So that
Yeah.
they're not necessarily um, like they could be mutually exclusive, like both front end and back end. But
Hmm.
what they're trying to offer here is kind of like a unified solution
Right.
where you don't have to worry about hosting a server on DO anymore. You can just go with the serverless approach and
Hmm.
you just create functions. Now there's a different paradigm in how do you develop and test and kind of develop locally with serverless. But I think once you work out those kinks, you'll realize that um, developing in that type of setting actually speeds up development tremendously because you're not worrying about this overhead or complexity or nuances of frameworks, right?
Hmm.
You're simply writing JavaScript functions, right? And so that kind of brings a lot of flexibility and um, efficiency in your development workflow.
Hmm.
And so that's I don't think that's just my own personal opinion. I think that's kind of the benefits that come out of the serverless approach. Now, having said that, not everything um, is a use case for serverless, right? So as we think about the types of things that we like to see on CodeBuddy, uh, these things are not like always running, right? These things are like, hey, I need to do an event happens, and that's when I trigger something like a Hangout, um, or I post something, right? Or I retrieve something. And so all of those things they lend well to something like a serverless architecture, right? You invoke something, you get something back, and you're done. You don't necessarily have to constantly be running it. Um, if there's other use cases that you feel that, you know what, I don't think that we do need like real time, always on, connected, then maybe that's a different approach you might have to take, right? Um, but for now, some of the major use cases that I see definitely look like they lend well to this approach. So
Yeah,
hopefully that made
yeah, that makes sense. Thank you.
no problem.
I think it'd be interesting to get a like napkin estimate of the costs for hosting on Netlify once we exceed the 125,000 requests and 100 hours per month. Because
Yeah, I think that's also an opportunity for Netlify to give us some bandwidth for free for open source projects.
okay,
And I think that there is something out there for open source projects that I think they will sponsor.
cool. Yeah, that's good to know.
So I like to explore that, which could certainly give us the ability to take advantage of like Lambda still. I don't know if it's just the Netlify front end hosting that they'll do for free, which I think that would make a lot of sense because everybody gets that for free today. So I think there's other add-ons on here as well, with Netlify. I mean, Netlify as a whole, as a product itself is amazing, but I'm just highlighting that we can take advantage of so many other things besides the serverless piece, but there is a ton of like add-ons in here, like identity and forms and all this stuff that you can add on. Of course, some of that stuff does come with a cost, but those are just things that that you will get with the platform like Netlify. My focus on this proof of concept was mostly on the functions component on the serverless piece. So, but I know that it has all these other goodies that it comes with it. So
cool. Yeah, I guess the reason I mention it is because DigitalOcean so far has been very generous in sponsoring our hosting. Like they've increased the amount of credits that we've had, like as we've been growing. So, I mean, like, of course, they could decide to stop sponsoring
sure.
at any year, but I feel like so far they've been very supportive. So potentially we wouldn't have to worry about hosting costs
Yeah.
with DigitalOcean right now. So I'm not entirely sure if like what the cost would be if we decide to use Netlify for the backend.
Right.
Yeah.
The other things to consider too, let's say they're both, if all things were equal in the sense of cost, like if Netlify offered the serverless component for free to open source, the benefit of going with Netlify obviously is the fact that as a contributor to the code base for Code Buddies, your development workflow will be significantly simplified, right? Because you're not worrying about deploying your code on your own through a CI server today, right? Netlify handles that for you.
I see.
Right? You're not setting up deployment scripts that you would deploy, that you have to integrate with like, something like Semaphore or CI Circle, and configure your build commands and everything to be able to run your tests and do all these things. Not to say that you still can't do that. Like obviously it makes sense for us to continue to leverage some CI capabilities. But in this case, you can actually leverage Netlify's deployment piece. So they'll deploy the Lambda functions for you. They'll deploy your front end for you. Out of the box, it will also give you the ability to deploy, provide builds for deploy previews from your pull requests, right? Which is pretty nifty.
Wow.
So anytime somebody does a PR, it would automatically deploy a unique URL that people can go to and test your application. And
Yeah,
it's
that's
built in,
what Seppo was working on. I think last year for
yeah,
COVID.
get yeah,
Yeah.
exactly. Yeah, I know you try to do it through Z
Hmm.
now, and this does it out of the box.
Cool.
Yeah, so a lot of build hooks, things like that, that you can do inside of Netlify. So, I think that there's, opportunity here that we can certainly leverage. Um, but kind of going back to just a run through of just the Netlify and serverless approach here, um, you know, the first thing is we want to ensure that we have to install the Netlify CLI locally. So, I set up some commands here that instructions on how to go ahead and do that. Clone the repo, and then do an npm install, and then they have a short command here or an alias to run netlify dev, which essentially runs your they call it the netlify dev server, or edge server is what they call it, I think. What essentially simulates their infrastructure locally on your machine.
Hmm.
um, and so the good thing about that is, if anybody knows, I'm sure you do, that it's difficult to do a one-to-one when you're developing locally and seeing what it actually looks like in production, right?
Hmm.
And so being able to do that locally, especially like in a serverless approach, is a huge benefit, to do that. So they were able to um, do that with the Netlify Edge and Dev platform here that runs literally on your platform. So they run their entire platform right on your laptop, locally, which is pretty amazing. So once you do that, and I'll kind of walk through an example here, you will essentially be running your front end application through a particular port, and then you'll also be exposing any Lambda functions through a particular URL, um, that you expose based on your configurations of your Lambda function. So the last piece here that we really haven't talked is that I also introduced the concept of using GraphQL.
Hmm.
So, in most typical applications, obviously we're still following the REST pattern. Node Express, it's typically written in the REST kind of pattern. And I think we do have a Node um, REST concept out there.
Yeah.
And that's pretty straightforward. I think that's also another viable option, absolutely. In fact, you can even leverage GraphQL in that same concept. Um, but that would require you to actually continuously run a backend server, right? In the Node Express, even if you add GraphQL to that, you have to continuously run that server somewhere, right?
Hmm.
In this case, I'm kind of getting both the best of both deals. Like, I'm not only able to run a GraphQL endpoint, but I'm running it in a serverless architecture. Um, so I gave some examples here. If I know that not a lot of people are familiar with GraphQL, and it's still kind of new kid on the block-ish, right? It's been around for a few years now, but I think now it's really starting to pick up steam. Um, I think for anybody who's spent enough time building APIs, especially on the REST architecture, or standard, uh, spend a weekend learning GraphQL, and you will see the tremendous benefits with GraphQL.
Hmm.
Again, though, that also, not everything could be a use case for GraphQL, but I haven't really found one that can't be one, right? There
Yeah.
are some learnings. I think there are some gotchas and some things that people are typically accustomed to when they're in the REST architecture. Um, but the community has really risen in the last few years to
Yeah.
build out libraries like Apollo, which is what we're using here, to address some of these shortcomings or some of these new things that people didn't consider when GraphQL came around, like caching, for example. And so, leveraging something that's been kind of battle tested and actually is being used in production today by other companies, I think is a good bet. And so, um, this is what I decided to use. So this is kind of the technology stack. You know, we're using Netlify to kind of host everything for us, CRA for the front end, the Lambda functions using Node via the Netlify functions, and then GraphQL using Apollo library.
Can you
So,
demonstrate a GraphQL setup?
what's that?
Can you demonstrate like how you would write GraphQL in here
Yeah,
to, yeah.
yeah, sure. So, so understanding that we're in this kind of Lambda context, don't let that kind of scare you, right? All we're doing here is creating, like if you were creating a Node Express backend, right? In how you structure your application shouldn't be very different from how you would typically do it in any Node application. The difference, though, is that you have to expose some handlers, right? You have to expose a function that gets invoked. But that also means that when you deploy your functions, they need to be properly bundled together, meaning all of the modules that your application depends on, your functions depend on, need to be bundled and imported in and packaged up and deployed. So that's the only gotchas that I know that I faced initially, is understanding that when I do bundle and build my functions, that they're properly built and they're bundled with all my dependencies. Netlify has somewhat simplified some of that process with some tooling. One of those is Netlify Lambda, which is what we're using in this project. Netlify Lambda basically allows us to build from a source directory, compiles all of that, and in our case, it also transpiles. So we have ES6 support out of the box, and bundles your Lambda functions and builds them and creates a build directory. And so when that gets deployed to production, Netlify will run these build commands for you, build those functions for you, and deploy them for you, and bundled up already. So outside of that, everything else is very typical. So having said that, this is kind of what the base requirements are. You're exporting a function called handler. This is like the only requirement in a Lambda function that you need to expose in here. And this handler function is what is actually managing and processing your requests from your front end or from any client that's calling your API, right? And so typically, this would, like in a Node kind of Express context, this would be your kind of request response kind of paradigm, right? Pattern.
Yeah.
The difference in here is that this signature here is actually coming from what we call an AWS API gateway. The gateway is this in between middle. Think about that kind of like a controller. This is like I don't know, maybe controllers and people who are coming from like Ruby on Rails, some of these controllers that handle the requests, but they route them to the right place. But in this case, the API gateway is going to route it to the AWS Lambda function. So once you understand that there's only certain what the signature looks like for a function, then you'll understand what comes with it. But ultimately, all of the requests that you're really dealing with is coming from this request object that you'll handle in whatever way you want, right? In this case, what I end up doing is at a very high level, there's, when it comes to GraphQL, you have schemas or types is what they call them, type definitions. In our case, we have a resources type, right? So this is what it will look like. So you define your type, and there is the concept or the notion of a query type. And this is what you are basically defining your API in, right? This is what I'm allowing the client to search on. Like if I run a query, you can search on resources, or you can search on resource, passing in the parameter of ID, right? And on the right-hand side, what we're telling GraphQL is that when they query for this, this is what the expected type that we're planning to return back to the client. And so it is strictly typed, right? I mean, out of the box, those are the things that come with it. And so you can see kind of the relationship here that when you search for a resource and you pass it an ID, you're going to get the shape of that response, right? The type of that response is going to be what I define it to look like. And in this case, I'm defining it with these particular fields, right? And so at a very high level, that's the first step, is defining your schema or your types definition inside of a GraphQL server. The second piece that's probably the most interesting part is your resolvers. So your resolvers are really your kind of meat and potatoes in how you actually return the data back, right? In this case, it's also, you'll notice that they are mirrors of each other between the resource, where I have the query here, resources and resource, and then how I'm defining that inside of my resolvers. Every single field inside of your schema here, or excuse me, every single field inside your query has to be resolved with a resolver function. So if I had 4 more fields here, 4 more queries in here that I define, that's what I'm exposing as my API. They all need to have resolvers functions tied to them. That's how you resolve the data back to the client.
Wait, so query is that, by the way, I don't know GraphQL at all. So is query what
That's
the data that we
GraphQL.
want returned?
Yes. So no,
Okay.
this is not the data you want to return. This is what you're telling the API or the client what they can search on. So in
Oh,
here,
as they're querying, wait,
yeah, and
as the user is searching on, or what the API is searching on?
So maybe if I give you an example here. So I'm going to run the server locally. The nice thing about the Netlify Lambda is it out of the text that you're using, or excuse me, Netlify local dev, it auto detects that you're using something like Netlify Lambda, so it'll automatically build your Lambda and then also fire up a local server for your front end, which is nice. So in this case, you notice that it created this built Lambda folder. Yep. In that it has my compiled now bundled GraphQL server function, my Lambda function entirely built for me. And so that's what you want, right? And that's what gets exposed to the client, or in this case, we're exposing this through a endpoint called, .netlify /functions / GraphQL, and that name here corresponds to the name that you give the function, right? If I call this Apollo, it would be / Apollo, right? Mm-hmm. So we're using this GraphQL Playground application, which is fantastic to be able to just run these queries yourself.
Oh, so that's a separate Mac app to download, right?
Yes, yes. And you can download it. It's pretty simple. It's pretty straightforward. So this is what a typical query looks like. And so if I back up a little bit here, you start off with this query, you open, close the brackets. The nice thing is that this GraphQL Playground is automatically querying my GraphQL API already. And the reason why it's doing that is because the nice thing about Apollo is that it provides this feature called introspection. And the introspection is almost self-identifying its own API and self-documenting it for you. So that's fantastic. So this is what I talk about the schema here. This is actually coming back from my server, and it's being pulled in from this application in what we call introspection. And so as you can see here, my type query, and I know that the queries that I can search on are these two, resources and resource. That matches my API that I built here. Right? You see how that matches? I got my resources, and then I got my resource type here. It's already recognizing what I'm allowed to even search on. It's even telling me what fields I can search on. So in this case, I can just start typing resources, and it would automatically autocomplete for you because it knows that these are the only fields you're allowed to search on. So if I select resources, and the beautiful thing about the query is that it's a graph, so it matches the way you search and what you actually get back, the shape that you get back matches what your query looks like. So in this case, I'm looking for resources, and then I'm going to nest that, and I'm going to say, okay, well, go search for resources, and I want you to return back. In this case, I know I can search on any of these fields, right? So maybe I'm interested in the title, and maybe the description, and then maybe credit, right? And then maybe just the URL. So if I query that, I hit play here, which is essentially going to run this post request over to my GraphQL endpoint. I run that, you'll see on the right-hand side that it returns back an object as a response with the data key. And then inside of that is an object with an array of my resources. And each one of those have exactly the fields that I asked for: title, description, credit, URL. If I take out credit, for example, I don't want it anymore. I decided part of my client requirements, I don't need it anymore.
So you're basically building out custom API endpoints for yourself in GraphQL.
Absolutely, but you're doing it from one endpoint. You don't create GraphQL /resources, GraphQL /resource /code and ID, right? You're not doing any of that. It's one single entry point. Mm-hmm. And your query here on the front end, you as the one that's responsible for, as a front end dev, you know what you need on the front end. So you'll just tell the backend developer like, hey, I want to be able to get this information back. But in the future, you know what? I changed my mind. I don't need that credit thing anymore. I don't have to go tell you to take it out of your response of your API. I just don't ask for it on front end anymore. Mm-hmm. Right? And so now if I run that, I immediately just get back the fields that I want. I didn't have to go tell the backend developer to say, hey, you need to update your API because your API response right now for resources endpoint gives me back credit and I don't need it. So you're oversending data and I'm overfetching it, right? So you don't have that problem.
I heard that GraphQL also lets you query from multiple API endpoints.
Yes, exactly. And so that's the other benefit too, right? So in this case, my resolvers is very simple right now. I'm just doing a static resources array, right, as my data store. But this data can easily be coming from a database, right? And what you do end up doing is you just create functions that go fetch the data from anywhere that you want. And you just create those functions and you just return the data that you return has to match the shape that you defined in your type. That's your only goal, right? So in this case, I know that when I go fetch one of these resources, like I know I have resource ID1 and ID2. So if I change this query to resource, for example, and I know that I need to pass in ID, it even lets me know this is what I need to pass in. Then so this first part is telling me, what am I searching for? Because this is the only thing I know that GraphQL endpoint allows me to search on, because I know that, because I want to look at the schema. I also know now the second half of this is I'm telling the query to tell me, this is what I want you to return back from that resource. So again, I can return back title, description, and URL. But it's only for one resource now. So if I hit play, I'm only getting that one resource back. And I know that that's the one because I can return back the ID, and it's ID1.
Nice.
That's pulling it from this array here. That makes sense?
Yep. Can you remind me what the query is used for in your GraphQL.js?
This one here?
Maybe not in that file. There was another file where you had in here where you had, I mean, I initially took it as the type resource. It was defining the schema for resource. But what is query again? Is it?
So these are GraphQL DSL. This is the DSL for GraphQL. It has three different types of types. One is query type, which is what you define as what you're allowed to search on your API. And so you're defining these types. Right?
Oh, I see. So that's why you were showing those two examples.
Exactly, because that's the only thing I can search on right now. Because
Sorry,
that's
what
the only
does DSL stand for?
Domain. I think it stands for domain syntax language. I think for any language, yeah. And so it's GraphQL's own syntax, essentially, its own language, how it defines its own specification, right?
Okay, so so again, I'm kind of guessing because I haven't taken GraphQL. I haven't looked at like the docs, but
Sure.
I'm assuming so. If you type in something like, let's say we had Hangouts, right, and that was defined elsewhere as a type Hangouts. Can we do something in our type query? Can we do something like Hangouts : and then it would draw from both type resource and type Hangouts so that we can get the data from both of those schemas?
So something like this, like if I have Hangouts,
Mm-hmm.
and then I need to define my Hangout type here, right? And I want that Hangout to be whatever I want it to return back, right? What if I want it to be the author, right? And I need to define what is this particular field type is, because everything is strictly typed in GraphQL. So you have to tell it what the type it is, because it protects you from the API as well, right? The client request, which is very nice, right? So in this case, it's a string, right? We know it's a string. Maybe we want the Hangout type, right? This can be, in this case, there is such thing as an enum that we can actually do in here. So, you can have things like, I think you have silent, right, Hangouts, and like teaching Hangouts, right, things like that. You actually can define that as an enum separately here, but not so we don't get too caught up on that or complex about it. We can just say, created at, right? That's a string. And anything else that you want to return back as what you want a Hangout to be, right?
Yeah, so so my question was more about like if we, in our type query, if we wanted to pull in data from two different types, like both resources and Hangouts, is there a way that we would write it so that
yeah,
Hangouts is equal
absolutely.
Yeah, so what is the syntax for that? Is it like
you would,
or something? This is kind of like like how would you query multiple tables question.
Yeah, so you're looking for like association here, right?
Yeah.
Yeah, so are you saying like I want to expose a query that returns back resources and hangouts?
Yeah, exactly. Like, say I want to list all of the resources that correspond to a hangout, or all the
Yeah,
hangouts that correspond to a single resource. Then
so
there,
it's like something
there,
like hangout by resource, right? Something
yep.
like that?
Hmm.
Yeah, and then you can pass in, if you wanted to, you can pass in the type or the resource type, I guess, right?
Yeah.
As your like parameter, right? Is whatever you want, how you want your query and API to be
Okay.
exposed, right?
So
But
you're just building up your own API right now.
you're literally
Yeah.
building your API here.
Yeah.
And so the resource type, in this case, is going to be a string, right? And then what you're saying is when they query for this, I want you to return back a type, right? And in this case, it's going to be an array of hangouts. See that?
Okay.
And
Um,
because you want to return hangouts by resource, right? And
oh, I
so
see. Yeah.
now by putting it around brackets, you're telling GraphQL that the response type here is going to be an array of these hangout types.
Hmm.
And so in this case, you have resources here,
So it would be
whatever
a
you,
foreign key back to the resource ID or something, right?
yeah, exactly. So it'll
Yeah.
be resource. See that? Right? It'll be an array of these resources right here. And then if you bang that, like shebang that, you're telling it it has to be a required field. This can't be null.
Oh,
In this
okay.
case,
I was
that
wondering what the thing meant. Cool.
yeah, yeah, it just means that it can't be null. You have to return something back.
Hmm.
And I mean, in some cases, it may not be applicable, right? I mean, maybe we don't find any hangouts by a resource because it hasn't been created yet, right? So, but that's what that is. So you see how now I can reference all the resources here based on the resource type, because now this type here is what I pass in here,
Hmm.
right? And then it'll query, then I create a resolver that does all the logic to return back this shape. But the nice thing is that once you return back all of the resources that you find out of your database that are, where the type equals this, GraphQL will know how to return back these resources because you've already defined that type already.
Hmm.
Does that make sense?
Yeah.
Cool. So it's pretty powerful. And so queries is the very first thing that you must define in order to even expose an API.
Hmm.
The second component to that is mutations. So mutations are your puts, your updates, your deletes, your creates. And so that's where you're creating stuff, mutating stuff. And so you create a mutation type. And in that mutation type, you create what you are allowed to call on the front end as a function name, if you will, to call it, say, for example, um, in this case, I'm doing, create resource, right? And so in here, when I create that resource, I just want you to return back my resource. In here, you pass in, you know, the resource, right? And so on the front end, you just compile that as a payload, and then I create a on the resolver side, I create a mutation function that resolves this, meaning it knows how to go and create this resource in the database and then just return back that object, and it'll return it back in this shape. And so on and so forth. You can create or delete or update a resource or create a hangout, right? Any of those things, these are your mutations.
Wait, so are they meant to be actions usually?
when you say actions, are you referring to
like creating, deleting, editing.
oh, yeah, yeah. I mean, mutations are in the like in the I guess in the context of like mutating data, that's what this really means, right? It's like,
Okay, cool. Got it.
yeah, yeah. So you're doing all those kind of typical CRUD operations, if you will, right? With the exception of the R, which is this. This is the read operations, and this is your kind of essentially your write operations.
Okay, yeah, thank you. I think when you were initially explaining, I missed that part, and then it makes a lot of sense now.
Yep,
Yeah,
yep,
this all makes me want to just take the plunge and do that Intro to GraphQL course or tutorial.
yeah.
So thank you
So yeah, so
for the yeah.
no problem. And so I think there's benefits, obviously, to using something like GraphQL because you have a clear definition of your API. Once you get past all the nitty-gritty and how to define your queries and whatnot,
Mhm,
I think you'll realize how quickly you can build an API and how quickly you can add and remove and update
mhm,
your API. The way that this current PLC is structured is just some some small like typical um, way of structuring an application that just helps you modularize it a little bit so it's more scalable.
mhm,
Um, and you'll see this typically in a lot of like Node Express applications, but so it's nothing overly complex. I like to keep things typically simple, types, resolvers. Ulib is like your utilities, your additional functions, helper functions, things like that. And then your initializers is typically kind of your setup kind of things, and making sure that once you fire up your GraphQL and it gets that first invocation, that it knows that I have to go and run the setup first to make sure that I'm importing my schema, that I'm initiating a new Apollo server instance, and now I'm waiting. I created my handle request function that I'm importing from my Apollo library and or helper function here, and now I can handle that request. In this case, as you can see here, the Apollo here just has, we're using the Apollo server Lambda kind of integration. Um, and all that really is doing under the hood is instantiating a typical Apollo server, but it's returning the response in an API gateway compliant format. And so that's a key point because you can't just respond back in the typical fashion like you would in any other way, like an Express server. You have to respond back in a format that the API gateway expects. And so the nice thing is that somebody in the community has already built this Apollo server integration with Lambda, and you don't have to worry about doing that formatting yourself. Um,
wow.
so if you follow the Apollo graph, uh, uh, yeah, apolograph.com. If you go to the docs here, really, really good. It gives you a breakdown, a tutorial, how to build a schema, how to hook up your data sources, and all this stuff. It's really good. And like I said, there's a lot of documentation, a lot of examples out there that can help you guys, kind of wrap your head around Apollo and GraphQL. And you'll see that I just follow a lot of typical kind of same setup here with a little bit of just additional kind of some nuances when it comes to asynchronous kind of function handling instead of Apollo and Lambda. That's the only kind of extra stuff in here that may not make sense off the bat, but once you hit a specific snag, you realize that, wait a second, this isn't working like I expected to work. So luckily somebody had a solution out there that made sense. And so we're just leveraging that same solution here. But definitely can peruse around that, how that gets initialized and then set up. And everything else is the bread and butter is really right here, creating your types and your resolvers, and then you're ready to go. So the last thing that I want to cover is deployment. So once we commit And right now I have it set up to my develop branch. So anytime that I do any merges into develop or any commits into develop, Netlify will automatically recognize that and deploy the application automatically. And we can set this up obviously in the future to build off our master branch, for example. And so, you can certainly choose whatever branch you want, but for now we just chose develop, but it would automatically deploy your stuff, and you'll see all the deployments here that I've ran. And you can go to the last one. I'll show you what it looks like Bill committed some API link to. He did this on September 16th, so that automatically deployed. Well, that was 2 days ago. And
I think that was actually me in the commit message referring to Bill.
Oh, what was he?
Oh, okay,
yeah. Okay, cool.
I mean, not that it matters, but just to clarify.
Cool.
Yeah.
There you go. And so, so you can see that this actually deployed, and then you'll see the preview here. And then this is pointing to the front end app, which is fantastic, right? And so this would be the React application. But behind the scenes, you actually, Netlify has exposed a endpoint that exposes your Lambda functions. In our case, GraphQL is our Lambda function. So it will be, whatever URL that they give you, .netlify /functions / the function name. And this is GraphQL. So this is actually live right now. And you can see here, if I run this query, it's going to return back that data for me. And so this is actually the one that's actually deployed on Netlify right now. So you can see that the GraphQL endpoint is running in prod.
So in our React app, will we be like using Axios and just
calling this? Yep.
Calling this. Okay.
Yep. Exactly. With the Apollo client, which the nice thing is that Apollo also exposes that they have a library for Apollo client and Apollo server. So which is pretty darn nice. And so I think that they have, let's see. I thought that they had, let's see. I thought it was inside of these docs, but I don't see it here anymore, which is weird. Oh, here we go. So you got the Apollo client. They have a React client already. And so, it's already built to, in other words, all this is doing is wrapping components, React components, and they're like just supercharging them, wrapping with built-in functionality to run GraphQL queries. But with like best practices around taking care of all the things like caching your data and as well as updating your UI. So handle all the life cycle hooks for you and all these things for you. The Apollo client will handle that for you. So my recommendation obviously would be to leverage this client with your React front end to call the GraphQL endpoint on the back end.
Okay.
Yeah. And they have fantastic support for all of these things, so they got Angular, Vue, Meteor, Ember, and of course React. So yeah, I think that there's definitely some opportunity there. I hope that kind of made sense. I know that I kind of went a little fast on the back end a little bit, but yeah, I mean, I think that's kind of the gist of it.
Yeah, thank you so much. I really appreciate the comprehensive code walkthrough. And my takeaways are, I mean, I I should be taking notes, but my takeaways are we should do like a napkin of some cost estimates. GraphQL is probably, we can, like, even if we don't go with Netlify, GraphQL seems like a really great tool to use. Netlify also has a lot of like really great features. Contributors would probably have to pick up or look into like the Apollo flavor of GraphQL.
Right. They don't
And
necessarily have to be tied down around the deployment piece. I think it would just be
yeah,
one or two of us who handles this setup.
yeah.
Everything else would be just commits and merges into the repo. Everything else will be handled behind the scenes.
So I did have one other question, which was in terms of user accounts and authentication. Do you know if there's a best practice for uh, handling that?
Yeah, I think just I think in a sense, like if we're using something like serverless Lambda, um, and I think this lends well to the Jamstack stuff too. Like leave that up to people who've already solved those problems for you. So I would consider leveraging solutions like Auth0, right? Or taking advantage of OAuth implementations with like GitHub and stuff like that. The nice thing about Netlify is that it actually comes with the ability to um, add on an identity service, and that one of those that are supported is GitHub. So you can actually run your entire user management through Netlify. And so that's an option, right? And so, here is, you being able to authenticate and register your users using their API, and that API will expose integration points. So here's your external provider logins, for example. So you can set up, um, GitHub, Google, right? We don't have to be limited to just Slack or GitHub, right? And so you can take advantage of that. That would allow you to authenticate right into the application.
That's very cool.
Yeah, that's pretty nifty. So these are all just like follow the standard OAuth protocol and standard. And so they already built the solution for you, and you just use the Netlify identity widget, just like Auth0. So this is like their Auth0 implementation, if you will, right? That you can leverage on there. So we don't have to worry about building our own authentication solution, right? We don't have to worry about that.
Yeah.
In fact, I would highly encourage that we don't. So, yeah. So that's one way that's typically handled, especially like in a Jamstack serverless kind of architecture.
Cool.
Yep.
What do you think are next steps for this repository?
Yeah, so I think, I would love to get more contributors to take a peek at this current POC. And, one thing to really flesh this out would be to, update the GraphQL API to include mutations like we just discussed here, so we can actually see data being stored somewhere. So that, and in addition to actually setting up a cloud-based data store, right? And see that like go through successfully, right? And like pick a service provider, or pick a cloud provider, database thing, and then configure that inside of the project. So when you deploy it, you can actually save data and it persists, or between deployments. So you can actually query new resources, and whatnot, or whatever the criteria that we're looking for right now, at least as a proof of concept. The Hangouts piece, I think that is not necessarily something that, depending on how we want to do that, if we want to leverage something like Zoom, it'd just be a matter of like invoking a URL, right? And so, but I don't know if we fleshed that out yet, like how we want that to look like.
Oh, you
But at a
mean
minimum,
which API we use for Hangouts?
yeah, like for Hangouts, stuff like that, like all we're doing here essentially on the back end and the API, we would probably just store like metadata of the Hangout and then expose that on the front end. So when they click on the button, the front end is actually calling Zoom or calling, right? It's
Yeah,
not like we're calling a back
yeah,
end.
that's what we do right now. Yeah.
Yeah, we're not necessarily creating, we don't have like a back end logic that actually creates the function or creates the Hangout itself, right? We don't have any of that. So I think in this case, it will still work, right? We'll just, when we create the Hangout or schedule the Hangout, if you will, we'll just be storing metadata about it and exposing like the URL or something like right here, and
Yeah.
whatever, and storing that in the database. So I'd love to see those three things, like update the mutations, create mutations, integrate some database that is cloud-based, obviously, has to be, and then deploy that. And then the last piece would be, does somebody take kind of the lead on building out the front end in the React app? It could be something like a really simple UI, right? To just display resources, display Hangout metadata, right? I don't know what else like that. I don't know how far gone in terms of like what we want to see for now.
Oh yeah,
But
I think for the proof of concept, we actually shouldn't be worrying about Hangouts.
yeah,
So sorry that I kind of led you in that direction earlier. When I was just curious about like how we would deal with joining data from two different tables.
yeah,
Like,
gotcha. Yep. Yeah, so those are the things I would like to see is get
mm,
fleshed out, is just somebody who will be eager to pick up the kind of like the Lambda architecture and then GraphQL and then everything else is pretty typical. Like there's a couple gotchas, there's a couple things that people need to consider, but a little more advanced in terms of like how Lambda functions, cache data, or create singletons, for example, if the same container is actually reused on subsequent implications. So you want to be careful where you instantiate things, but that's mostly around performance and runtime, execution runtime. And so those are the things that we can certainly discuss if we ever want to move with this forward as a actual real thing, right? But anybody else who's willing to just jump in and learn about GraphQL and Lambda, I think this would be a perfect opportunity. And I think we have plenty of people who already are willing to probably contribute to React on the front end. So there's plenty of opportunity to do that in this particular proof of concept project here. And I think we can flesh out like a mini app here on the front end, flesh out the back end with mutations. And I think that's literally the extent of the entire proof of concept that will prove it out. Are you there?
sorry, I was muted. Yeah, thank you so much. I was just saying I started typing out a couple of notes on the bicep pad, the share document. So I was about next steps that you mentioned. But
Cool.
yeah, this was really helpful.
Cool.
Yeah, I'm looking forward to getting some more contributors to help finish up this prototype.
Yeah, and I'll continue to work on it as best I can. I kind of lean towards the back end more, but we're kind of living in the world today where, we're kind of living both spaces. So, and so totally comfortable with working on the front end too, if I needed to. So it's just a matter of trying to get other people an opportunity to kind of contribute if they'd like to.
Cool.
All right. So I think that's all I got.
Yeah. Yeah, that was wonderful. Thank you again.
Not a problem.